Hey, it's Coach Latham, your SOL math review coach, and today we're going to talk about exponents and radicals, a topic in Algebra 1. And as always, we're going to do it in under 15 minutes. The first thing is just a review of what we're talking about here. Now, we've got 3 squared, which means that 3 is being multiplied by itself 2 times. The exponent tells you how many times the base is being multiplied by itself. So 3 squared is 9. 2 cubed would be 2 times 2 times 2, which is 8. So that's how exponents work. Here's a table I want to fill in. We're going to prove 3 of the rules for exponents just by filling this table in. What I've got over here, this is the base, and then up above these columns are the powers that we're going to raise them to. So let's work with the 2 first and start over at the very right. What I'm looking for here is 2 cubed. And 2 cubed is 2 times 2 times 2. Well, we already said that that was 8. And then here I've got 2 squared. 2 times 2 is 4. And then in this column, I'm going to have 2 to the first. Any number raised to the first power is itself, so that's simply 2. And then this, I'm going to have 2 to the 0 power. Anything to the 0 power is 1. 2 to the negative 1 is going to be the same as 1 over 2 to the first. If I've got a negative exponent, it becomes a positive exponent on the bottom of the fraction. Well, we've already said that 2 to the first is 2, so it's just 1/2. And then 2 to the negative 2 is going to be 1 over 2 squared, which is 1/4. Let's do the same thing with 10. We'll start back over here at the right. 10 cubed is going to be 10 times 10 times 10, which is 1,000. And we've got 10 squared, which is 10 times 10, which is 100. And we've got 10 to the first. Anything to the first power is itself, so that's 10. We've got 10 to the 0. Anything to the 0 power is always 1. We've got 10 to the negative 1, which is 1 over 10 to the first, which is 1/10. And then finally we have 10 to the negative 2, which is 1 over 10 squared, which is 100. And so this is what we get. And this is kind of a proof of these 3 rules at the bottom of the board. Anything to the first power is itself. Anything to the 0 power is 1. And anything with a negative exponent, like x to the negative a, you just put it on the bottom of the fraction, and it's 1 over x to the a. The other thing that I'd like to take a second to point out here is that this bottom one, since we have 10 fingers, is really our whole place value system. We have the thousands place, the hundreds place, the tens place, the ones place, the tenths place, and the hundreds place. Actually reversed when we start writing numbers, but this gives you an idea as to why that works. All right, we want to write these out in long form and fill in the answers. Well, we're not going to fill in the answers right now, but 2 to the 5th is 2 times 2 times 2 times 2 times 2, 2 being multiplied 5 times. Negative 2 to the 4th, since the negative 2 is in parentheses, it's all going to be to the 4th power, so this one's going to be negative 2 times negative 2 times negative 2 times negative 2. That's going to give you a positive answer because there's 4 negatives in there. This one at the bottom, the negative is not in the parentheses, so it's going to just be 1 negative. And then the only thing that's being raised to the 4th power is the 2, so this one's going to be a negative answer. I guess I should put the answers in here. 2, 4, 8, 16, 32. 2, 4, 8, 16, and it's a positive 16 because there were an even number of negatives. 2, 4, 8, 16, and it's a negative 16 because we have 1 negative in this problem. All right, over here we've got 3/5 squared, so that's 3/5 times 3/5. 3 times 3 is 9, 5 times 5 is 25, and that's your answer. And then down here we've got 2 cubed times 2 squared, and this is really a proof of what we're moving into. 2 is being multiplied 3 times here. 2, 2, 2. 2 is being multiplied 2 times here. 2, 2, which is 5 2's being multiplied out. 2, 4, 8, 16, 32, so the answer is 32. This kind of leads us to our first rule, that if you're going to multiply these things together, what you really get is 2 to the 5th. So adding the exponents gets us to the answer. These are the next three rules that we're going to look at right here. We've got x to the a times x to the b is equal to x to the a plus b. Well, in algebra, it looks like this. If you had x squared times x cubed, you get x to the 5th, not x to the 6th, just like the problem we just worked out on the board. If we had y to the 10th times y, well, remember, this y sitting by itself is really y to the 1st, so the answer is y to the 11th. A harder one that we've seen on tests before would be something like this. 3x squared times 2x to the 5th. Well, 3 times 2 is 6. And then x squared times x to the 5th is x to the 7th. All right, likewise, if we divide things that have exponents, the exponents get subtracted. So if we had something like x to the 5th over x squared, we would say 5 minus 2 is 3, and get x to the 3rd. The one that shows up on test all the time is something like this. X to the 8th over x to the 2nd. They want you to fall for the answer being an exponent of 4, because 8 divided by 2 is 4. But remember, when we divide things that have exponents, the exponents get subtracted. So x minus 2 is 6. And then finally, we've got this one down here. We've got a power to a power. And it could be something like this, x squared cubed. And what we're saying is, if you have something like that, you can multiply to 2 times a 3, and the answer is 6. You can prove this to yourself, or you can just about always do the problem by just converting it back to a multiplication problem. X squared cubed is x squared times x squared times x squared, and if you add 2 and 2 and 2, you get x to the 6th. So what I'd like for you to do now is to hit pause and try these three problems on your own. These are three problems off of old SOL test. So go ahead and hit pause. Okay, we're back. We're going to go ahead and solve these three problems real quickly. It says to simplify these and write them without negative exponents. That's a common rule that you'll see. First one, 18 divided by 9. That's always 2. They're just regular numbers. C to the 8th divided by C to the 3rd. 8 minus 3 is 5, so that's going to be C to the 5th. And D to the 9th divided by D to the 3rd, 9 minus 3 gives you 6. Okay, looking at this second problem on the right here, I'm just going to go ahead and write this one out. It's all this junk in here being squared, so it's going to be 3y over 2x cubed times 3y over 2x cubed. And then 3 times 3 is 9. Y times y is y squared. For the bottom, 2 times 2 is 4. And then x cubed times x cubed is x to the 6th. So there's that answer. This one at the problem at the bottom is a little bit more difficult than the others. It takes a few steps. I'll go ahead and move it up there. All right, but I'm going to write this first part out long way. So it's going to be 3x to the negative 2 times 3x to the negative 2. And then we've also got the 5x to the negative 3 there. All right, once I get here, I'm in pretty good shape. 3 times 5, that's the hardest part of this problem for me, is 45. And then x to the negative 2, x to the negative 2, x to the negative 3, add negative 2, and negative 3, and you get negative 7, which is just 45 over x to the 7th. Remember, when you have a negative exponent, you move it to the bottom of the fraction, it becomes positive. Radicals, square root of 9 equals 3. Why? Because 3 times 3 is 9. We don't always put a 2 here. In fact, we don't. But remember, if there's not a number right up here sitting on the corner of that radical, it's assumed it's a 2. So we're looking for the number that is multiplied 2 times to get to 9. Down here, we've got the cube root of the cube root of 8. And the answer to that is going to be 2, because 2 times 2 times 2 is 8. This is what the problems look like in algebra. You have to take the square root of this right here. The square root of 25 is going to be 5, because 5 times 5 is 25. The square root of x to the 8th. You always have to have an even exponent. You take half of it. Half of 8 is 4. So it's x to the 4th, and the square root of y to the 6th is y to the 3rd, because half of 6 is 3. If you multiplied this back out based on the rules we just learned, you would see that we get that. 5 times 5 is 25. X to the 4th times x to the 4th is x to the 8th, and so on. We do the same thing down here. Square root of 16 is 4. Square root of x squared is just x, or x to the 1st. Square root of y to the 10th is y to the 5th. They're not always that easy. Sometimes you have to factor out your perfect squares. These are the numbers that you really have to memorize. The 4, the 9, the 16, 25, 36, and 100. The exponents are easier. You just need to have an even exponent. Let's take a look at this one right here. We've got the square root of 25. Well, the perfect part of 50 is 25. 25 times 2 is 50. We can take the square root of this part, and so the answer is 5 square roots of 2. We break down the 50 to 25 times 2. We take the square root of 25, and we have a leftover of the square root of 2. Taking a look at this one right here, we do it the same way. The perfect part of 8 is 4 with a 2 left over. 4 times 2 is 8, and we know what the square root of 4 is. For x cubed, x squared is the perfect part, and x is a leftover. We can figure out the square root of x squared, but we got to leave the extra x left inside. So our answer is going to be 2x, the square root of 4 is 2, the square root of x squared is x, times our square root of 2x left over on the inside. We'll do this one down here the same way. The perfect part of 200 is 100 with a 2 left over. The perfect part of x to the 9th is x to the 8th with an x left over. So we can take the square root of this stuff, 10x to the 4th, and we got a 2x left on the inside. On this final example, well, there's no perfect part that factors out of 3. 3 is all left over. X to the 21st, we can take x to the 20 as perfect with an x left over, and y to the 8th is all perfect. So this is the stuff we can take the square root of, which is going to be x to the 10th, y to the 4th, and we have a 3x left inside. What I'd like for you to do right now is to hit pause and try these two. Okay, we're back. I don't think these two are any harder than the ones that we just did. These are, however, off of previous SOL test. The first one over here, we've got the square root of 18. The perfect part of 18 is 9. And our leftover is 2. 9 times 2 is 18. And we know that the square root of 9 can come outside and be a 3. So our final answer is 3 square roots of 2. We'll do the same thing on this last one. But it turns out that there is no perfect square that factors out of 42. The factors of 42 are like 7 and 6 and 2 and stuff like that. And that doesn't help us. So we're just, the 42 is left over. N to the 8th, or to the 9th, can be factored as n to the 8th with an n left over. So when we go to finish this, that comes outside, n to the 4th, and we've got a 42n left over. Hopefully this has helped. This was exponents and radicals, the things you need to know in Algebra 1, and as always, it's been under 15 minutes. Now go out there and study.